Right now, a machine is humming in your kitchen, quietly running on a technology that hasn't fundamentally changed in nearly a century. Every standard refrigerator on the planet relies on the exact same mechanical process: vapor compression. It uses a noisy, vibrating pump called a compressor to force chemical gases through narrow metal pipes, slowly wearing down its internal moving parts 24 hours a day. Beyond the constant noise and guaranteed mechanical failure, this system conceals a massive environmental threat. Common refrigerant gases like R134A possess a global warming potential over 1,400 times greater than carbon dioxide. A single minor leak from millions of household units silently leaks heat-trapping pollutants into the atmosphere, making conventional cooling one of the most destructive hidden liabilities of modern infrastructure. But in a quiet physics laboratory in Beijing, researchers have just unlocked a breakthrough that could render traditional compressors completely obsolete. Scientists at the Chinese Academy of Sciences have constructed a revolutionary solid-state cooling machine that uses zero chemical gases, zero refrigerant liquids, and virtually no moving parts. By replacing fragile pumps with a targeted magnetic field and solid metal alloys, China has solved a century-old thermodynamic puzzle, laying the foundation for a silent, leak-free future of refrigeration. If scaled to mass production, this single invention won't just reinvent your household kitchen, it will dismantle a $100 billion global industry from the ground up. To understand how this machine functions without a single pump, you have to look back at a physical phenomenon discovered in 1881 known as the magnetocaloric effect. When a strong magnetic field is applied to specific metal alloys, their internal atomic structure is forced to line up in a neat, orderly grid. This sudden alignment generates heat. When the magnetic field is removed, the atoms scatter back into disarray, rapidly absorbing surrounding heat and cooling the material down. For over a century, this phenomenon remained trapped in laboratories because previous prototypes relied on water or liquid coolants to transfer that cold air. The liquid acted as a massive bottleneck, flowing far too slowly to compete with the rapid cooling speed of traditional kitchen fridges. That is precisely the hurdle the Beijing team shattered. Led by researchers at the Institute of Physics, Chinese scientists developed a fully solid-state hybrid magnetic regenerator, completely eliminating liquids from the equation. Instead of waiting for slow fluid to carry temperature changes, they layered the magnetic material directly against a solid, highly conductive metal block. By enabling instant solid-to-solid heat transfer, the device cycles magnetic fields at unprecedented speeds without any risk of leaks, friction, or wear. This solid-state architecture bridges the gap between an obscure physics experiment and an ultra-efficient, silent technology capable of outperforming standard compressors. The implications of this solid-state breakthrough extend far beyond keeping household groceries cold. Because this system operates without fluid loops, bulky pumps, or fragile seals, it can be scaled down into microscopic dimensions to act as a precision thermal scalpel. Modern high-performance electronics, from advanced AI server chips and high-capacity electric vehicle batteries to compact smartphone processors, generate intense heat in concentrated microspots. Traditional cooling fans and liquid cooling loops are often too bulky, prone to leaks, and inefficient at targeting localized hotspots. A solid-state magnetic cooling module can be embedded directly onto a semiconductor, pulling heat away instantly without mechanical vibration, fan noise, or risk of fluid damage. This versatility transforms a simple refrigeration alternative into a universal thermal management platform for next-generation technology. Electric vehicle battery packs equipped with magnetic cooling could operate at peak efficiency during rapid charging sessions without overheating, significantly extending overall battery lifespans. Meanwhile, massive data centers that currently consume billions of gallons of water and immense grid power for cooling could cut their energy footprint dramatically. From silent spacecraft electronics to zero-vibration medical devices, China's solid-state magnetic technology provides a clean, silent, and maintenance-free solution to one of engineering's oldest problems: how to control heat without wearing down the machine. Despite its immense potential, transitioning this solid-state technology from a laboratory prototype into mass-market commercial appliances presents formidable engineering and economic hurdles. The primary obstacle remains the high cost of raw materials. The specialized magnetocaloric alloys used in the Beijing experiments rely on rare earth elements like gadolinium, which are expensive to mine and process compared to standard copper and steel. Furthermore, generating a magnetic field strong enough to cycle thermal energy efficiently requires powerful, highly compact permanent magnets, significantly inflating initial manufacturing costs. Until materials scientists synthesize cheaper, abundant alloys that deliver the same magnetocaloric performance at room temperature, solid-state magnetic refrigerators will remain cost-prohibitive for average consumers compared to mass-produced compressor units that have benefited from 100 years of supply chain optimization. However, as manufacturing techniques scale and synthetic rare earth alternatives emerge, China's solid-state innovation marks an irreversible turning point in thermal engineering. The team at the Chinese Academy of Sciences has successfully dismantled a century-old physical bottleneck, proving that high-speed, liquid-free magnetic cooling is not just theoretical, it works. As global regulations tighten on greenhouse gases and tech giants scramble for silent, efficient heat management solutions, solid-state magnetic cooling is positioned to disrupt every industry relying on temperature control. The humming compressor in your kitchen may still have a few years left, but its days are officially numbered as the silent, magnet-driven revolution takes hold. If you want to stay ahead of the curve on the technological and industrial breakthroughs shaping our world, make sure to hit that like button, subscribe to Global Engine, and drop a comment below on which everyday machine you think will disappear next.